So you're starting your thesis, and if you're like most people, you've probably hit a wall thinking, okay, how many people do I actually need for my study? And then, what in the world do I do with all that data once I get it? You're not alone. These two questions about sample size and statistics can feel, well, pretty paralyzing. So let's break them down and build a clear foundation you can actually use. I mean, these are the big ones, aren't they? How many subjects do I need? Which statistical test is the right one? They come up all the time. My goal here is to get you from feeling kind of uncertain about these questions to being able to answer them with real confidence. All right, first up, sample size. A common trap is thinking that bigger is always better, but it's not. The real goal is to find that just enough number. Just enough to make your findings credible, but not so many that you're wasting time, money, and resources. At its core, sample size is really simple. It's just the number of participants you need to confidently say something about a whole population based on the smaller group you actually get to study. That's it. You study the sample to understand the whole. And believe me, getting this number wrong has some real consequences. If you go too small, you might completely miss a real effect, which makes your study look weak or, as you'll hear, underpowered. But if you go too large, you're just wasting valuable time and money, and you're exposing more people to your study than necessary. So this isn't just a numbers game, right? Getting the sample size right is fundamental to doing good ethical science. To make this idea really stick, let's use an analogy. I want you to think of your study's findings as a photograph. And if that's the case, then your sample size is kind of like the resolution of the camera. See, if you have too few participants, it's like taking a low-resolution picture. The image of the truth you get is blurry. You can't confidently make out the important details. But with enough participants, you get that clear, sharp picture you really need to make your point. So what actually goes into calculating this magic number? Well, think of it like a recipe with 4 key ingredients. First, you've got alpha. That's your risk of a false positive, saying you found something when it isn't really there. Next is power, which is the opposite. It's your chance of finding a real effect if it truly exists. Then there's effect size. Are you looking for a massive, obvious difference or something small and subtle? And finally, there's variability, which is just how spread out your data is naturally. You have to consider all 4 of these to get it right. Okay, so once you have an idea of your sample size, the next logical step is to plan your analysis. And the key here is choosing the right tools for the job before you even start collecting a single piece of data. Think of it this way, you wouldn't use a ruler to measure temperature, right? The tool has to match the job. It's exactly the same with statistics. Your statistical test has to be a perfect match for your research question and the type of data you have. Before you even think about opening a stats program, just walk through this simple checklist. First step, what is the single most important thing you're measuring? That's your primary outcome. Step 2, how are you measuring it? Is it a simple yes or no, what we call binary, or is it a number on a scale, which is continuous? Step 3, what's your goal here? Are you just estimating a value or are you comparing different groups? And finally, step 4, do your homework. Look at what other studies found to get a feel for the numbers you can expect. Answering these questions first makes everything that follows so much easier. Now, this slide here is basically a simplified map to get you started. For instance, if your outcome is categorical, like yes or no, and you're comparing 2 groups, you might start by looking at a chi-square test. If your outcome is a continuous number and you're comparing 2 groups, an independent t-test is a really common choice. And if you have more than 2 groups with that continuous outcome, you'd probably look at something called ANOVA. Now, this isn't a complete list, obviously, but it's a fantastic starting point for some of the most common thesis situations. One of the best ways to get something right is to understand how it usually goes wrong. So let's talk about a few of the most common mistakes that can really derail a thesis. Here are the big 4. First, jumping straight to a sample size formula before you've even locked down your primary outcome. Second, just copying a sample size from a paper you read without understanding why they chose it. Third, collecting all your data and then trying to figure out which test to use, that's a huge no-no. And finally, only reporting that p-value without giving any context, like effect sizes or confidence intervals. Please avoid these. So, at the end of the day, all of this planning is really about one thing: successfully defending your work. Let's pull back the curtain a bit and talk about what your examiners are really looking for when they review your methods section. And this quote just says it all, doesn't it? Your examiners are not going to be impressed by some super complex statistical method that you can't actually explain. What impresses them is when you use the correct method and can clearly and logically explain why you chose it. Clarity beats complexity every single time. So, if you only remember 3 things from all this, let it be these. Number 1, Your sample size needs a clear, logical justification. Number 2, your statistical methods have to be a direct match for your research question. And number 3, a simple, well-reasoned analysis plan is always your strongest defense. So as you move forward with your own work, I want you to keep this one question in your mind. Is my research plan designed for clarity? Because a clear plan leads to a thesis that's not just easier to write, but a whole lot easier to defend. Thanks for tuning in.